If it is a wired link means, then what we are going to do is we are going to have a coaxial cable between the two links, and these links share the data between the transmitter and the receiver end. Whereas if it is a wireless means, then what we should do is we should see what is the range that a link we are establishing from the transmitter to receiver end. If it is belongs to wireless LAN technology, that is a wireless local area technology means, then the range may be around 100 meters or 200 meters depending upon the capacity of the network. So we need to transfer the data depending on the range. So we need to fix the range based upon the range what we are going to fix. So we need to adopt, or we need to select the appropriate modulation coding schemes so that the data will be transmitted successfully from transmitter to receiver without any loss of data in between the transmission media. Okay, so what type of modulation schemes you need to use, how we need to transfer the bits, okay, how it is generating a stream of bits, so all those responsibility will be belongs to a physical layer. Okay, the next one is the data link layer. So you can see here in the physical layer there will be a logical connection from the upper layer, means the second layer is the data link layer. So this physical layer, it is logically connected to data link layer. So whatever the data which will be generated from the data link layer, it will be converted or it will be represented in the form of bits, and these bits will be converted into electrical signal, and these electrical signals will be transmitted over the transmission media. If it is a cable means, then we can either we can send through electrical signals or we can send through light rays. If we are sending through electrical rays means, then the transmission media obviously it has to be an optical cables. Okay, so the next one is data link layer. The main aim of this data link layer is to frame the packets, or it is to generate the frames which are being generated, generate the frames for the information what it is received at the data link layer. Okay, and sometimes whatever the protocol we are going to use in data link layer, they may include error correction, error detection. Some protocols it will be functioning in the data link layer. Okay, so depending upon the what type of link we are establishing, based upon that either we can call it as a WLAN technology, or we can call it as a WAN technology, or it may be a wired LAN or a wired WLAN technology we can call. Okay, so here in data link layer, the main job is to receive the information from the upper layer. The upper layer is a network layer, so it receives the information from the network layer, and after receiving the data from the network layer, it will do or it will generate the datagram, or it will generate the data in the form of frames, we are going to call it. Okay, so the next one is we are going to call it as a network layer. So the network layer is responsible for data transmission between host to host data communication. Okay, so once again I'm telling, network layer it is responsible to have a data transmission between the host to host. So it uses a IP protocol, that is a internet protocol. So based upon the internet protocol, it will transfer the data from one host to another host. So host may be, it may be a computer, it may be a mobile, it may be a node. Okay, so all these terminologies we will be nomenclature for the host device. Okay, so it will responsible for transmission of the data from one host to another host. So that job will be done by the network layer. So in order to facilitate the application, or in order to facilitate the future layers of this application layer, that is the internet protocol, so we are going to use some subsequent protocols in order to facilitate the functionalities which has been carried out by the network layer. So what are the functionalities we will be using? So we will be using one of the simple protocol called as the internet control message protocol, that is nothing but ICMP. It is used to report if there is any error when we are routing the packet. So why it is called as a routing the packet means, if the source and destination are too far apart from physically, too far apartment, then we cannot directly transmit the data from transmitter to receiver directly. So what we are going to do is we are going to use the intermediate devices which are there in the within the network. So I will transmit the data to the neighboring node, and this neighboring node will receive the data, and it will see to whom I need to transmit next. So how it will get to know? Through the use of routing table. So one of the important functionality what we are going to implement in the network layer protocol is nothing but a generation and creation of the routing table. So each node, when it receives the information, it will see the routing table. So through the routing table, it will get to know that who is the data, from which device the data is being generated, and to whom device the destination address it will get to know, and who is next nearer to that destination it will get to know from the routing table. So based upon the routing table, the packet will be rerouted, or it will be directed to the destination. So that is the job of this network layer. So along with, in order to facilitate functionalities of the network layer, we will be using the internet group message control protocol and also the dynamic host configuration protocol, in order to make sure that what is the IP address of the corresponding destination of the destination and the source addresses. Okay, so we will be using these protocols in the internet protocol, that is a network layer protocol. Okay, and so as I said, so this thing you need to remember. So what you need to remember is network layer, it is responsible for host to host communication. It uses a protocol called internet protocol. Internet, that is IP protocol it uses. So there are two versions of internet protocols are there. One is IPv4 and one more is IPv6. The IPv4 and IPv6, how they are differentiated and why we have a two types of internet protocols. So all those details we will be studying in a subsequent chapter. But as of now, you need to remember that there are two IP protocols are there. We are going to call it as an internet protocol version 4 and internet protocol version number 6. Among this, internet protocol version number 6 is the latest one when you compare to the IPv4 version. So nowadays we are using IPv6 version of protocols is in order to nomenclature, or in order to define the device addresses, okay, within the network. The next layer we are going to call it as a transport layer protocol. So this transport layer protocol, it is also called as a end-to-end protocol. Transport layer protocol, it is also called as a end-to-end protocol. So why it is called as a end-to-end protocol means wherever the data has been generated, or which application the data has been generated, so to that application only at the receiver side the data has to be submitted, or it has to be delivered. So therefore, whatever, when the data is being generated from any computer, irrespective of the data or from what are the data that is there flowing at the destination side, then the corresponding application only the data has to be received. So therefore, this data link layer will responsible to transmit data from one process to another process. So therefore, it is called as the end-to-end data transmission. It is responsible for transmission of the data from end of the process to, from transmitter to end process of the receiver end. Okay, and along with this data transmission, this transport layer protocol will facilitate some additional features, so like flow control, error control, congestion control within the network. So these are the three important facilitates or additional features will be provided by the transport layer protocol. So this transport layer protocol, we have a two types of transport layer protocol as I discussed in the previous class. One is called as a transmission control protocol, that is nothing but TCP protocol, and one more we are going to call it as a UDP protocol, that is nothing but a user datagram protocol. Okay, so there is a difference between the transmission control protocol and a user datagram protocol. So what are the differences is that in transmission control protocol, there is a connection will be established before the data will be transmitted from transmitter end to the receiver end, means logical connection. We're going to call it as it is a connection oriented protocol. So before I want to transmit a data to someone, I will make sure that the someone is active and he is ready to receive the data. So I will get a signals from the receiver that yes, I am ready, you can transmit the data. So if the receiver acknowledge me to transmit the data, means then only I will transmit the data. So means what, in TCP protocol, that is in a transmission control protocol, before transmitting the data I will be verifying whether the receiver is active and he can receive the data or not, my through some signaling signals. Okay, so therefore we are going to call it as a TCP protocol is a connection oriented protocol, whereas UDP, that is a user datagram protocol, we are going to call it as a connection less oriented protocol or connection less protocol. Why it is called as a connectionless protocol is whenever I want to transmit to any someone, I will not get any acknowledgement from the receiver. Irrespective whether the data has been transmitted or not, I will simply forward my packet. So it's a job of the receiver to receive the data. If it receives the data, it's well and good. If it doesn't receive the data, means then the packet will be lost. Okay, so therefore, if you compare the performance of the TCP protocol and UDP protocol, TCP protocol stands ahead with respect to the UDP protocol. Why? Because before making any connection or before transmission of the data, since I am getting acknowledgement from the receiver that yes, you can transmit the data, so I will transmit the data. So once I transmit the data in transmission control protocol, I will wait from the receiver to get acknowledgement. Okay, so if I transmit an 8-bit of packet, I will wait for some period of time. So the receiver will receive the packet and he will transmit return back with acknowledgement signal. So through the use of acknowledgement signal, the sender will get to know that whether the packet has been reached to the destination within time with proper any loss in the signal. So if the transmitter get the signal, the acknowledgement that the packet what it has been transmitted, then only he will go for the next packet to be transmitted. So therefore this transmission control protocol, it is a reliable communication. Why it is reliable means we are sure that the packet loss will be minimum in the case of TCP control protocol. So therefore it is called as a reliable data transmission, or it is also called as a reliable data control. So since there is a logical connection between the transmitter and receiver end, so we can establish a flow control and error control during the data transmission from transmitter end to receiver end. So therefore TCP will provide a flow control and error control between the data transmission. Whereas one more protocol, as we have discussed, that is nothing but user datagram protocol. So in user datagram protocol, what happens is irrespective of the whether the connection has been established or not between the transmitter and receiver, data will be transmitted. So if the receiver is ready, he will receive, or else the data will be lost. So therefore, whenever an application does not require the guarantee that a receiver has to receive all the packet which has transmitted by the transmitter, means then we go for a user datagram protocol, that is nothing but a UDP protocol. So since there is no logical connection or a connection oriented scenario in the case of transmitter to receiver in the case of UDP protocol, therefore it does not provide any flow control or error control, and it does not provide a congestion control within the network. Okay, so along with this TCP protocol, along with this UDP protocol, recently we have come up with one more version of the transport layer protocol, that we are going to call it as a stream control transmission protocol. So this stream control transmission protocol, it is established or it has been implemented in order to facilitate the data transmission for the multimedia application. So if your data or whatever the data which has been generated in the application, if it is a multimedia application, means then it is best possible solution to use a stream control transmission protocol, so that the data will be transmitted successfully to the receiver with a minimum loss depending upon the type of transmission media what it is there between the transmitter and the receiver. Okay, so these are the layers what we have studied in the yesterday's class, and the final one is the application layer. So the application layer is the layer where the data will be generated, or finally where the user will interact with the application. Okay, so when I want to transmit any data through my mobile phone, means what I will do, I will open my application. Let's say I want to transmit some hi message to all of you, means I will open WhatsApp. In that WhatsApp, I will open a 6th, 15 and 17 scheme batch student, that is group, and I will type hi. So means what? even though your device it is receiving the data, so you should route the packet in such a way that the data has to reach the particular application, because there are so many applications will be running in your system. So you need to specifically mention that to which application the data has to be reached. Okay, so therefore that job has to be done by the transport layer protocol. Along with transportation layer protocol, a network layer protocol also facilitate in a generation of and creation of frames for data transmission. Okay, so we have a different types of application layer protocols. So some of the application layer protocols has been listed over here. So you can see here the application layer protocol is always it is supported by the hypertext transfer protocol. So whatever the application layer protocol you are going to use, it will be work under the provision of the hypertext transport layer protocol, that is HTTP. So recently we have come up with in order to improve the security to this your hypertext transfer protocol. So enhanced version of this hypertext transport layer protocol that has been emerged in the recent time, that we are going to call it as a hypertext transfer protocol for the security. Okay, so you can see here when you open any browser. So now recently we initially we used to get HTTP, but whereas now you can see here along with HTTP there is one more HTTP, there is one more symbol will be added, that is nothing but yes. So yes corresponds to security. So that is also an application layer protocol. So along with that application layer protocol, we have some other application layer protocol which will facilitate us to transfer the data successfully between the transmitter and receiver. So one of the simple transport layer, there is a application layer protocol is nothing but simple mail transport layer protocol and a file transfer protocol. So these are the two important protocols which will be using in the application layer. Okay, so this is all about your different layers. I request everyone you please make a note of this diagram and tell me once you complete. Please make a note of this diagram.
Sir, can I?
Just tell me.
Sir, encapsulation you want me to tell or what, sir?
What are the steps you are going to take in order to take one letter, that is one you want to post that letter, you want to write to someone who is far away from you.
Sir,
So what are the
for
stages?
a particular person, we need to write a letter. We need to address and from address. So
Okay.
from address, we'll be writing it. We'll write
Mm,
the to address, and then we'll write to whom are we writing the letter, then the subject,
mm,
the detail in the letter, and thank
mm,
you. Then from whomever we are sending, we'll wrap it up, we'll post it, and then postal address we have to paste. And for the
mm,
clear communication, we have to
mm.
write pin code and all those things on the envelope.
Yes. So the same thing we will be doing it in a computer network when we want to transfer the data. So as Shreyas said, so what we should do is we should write a source address. So means to whom the letter is coming. So we should write a source address. Means we should write our own address. Next, to whom we are sending. So we should write the name and along with the address we need to write. And inside that what we will do is we will write whatever the information it has to be written. So we will write it and we will put it in an envelope, and for that on top of that we will attach it. So what we will attach is we will attach a sender address and a receiver address, and what we will do is we will put it in a post box. So this postman, what they will do, they will correct that letter and they will do some formalities. So what formalities they will do it? So before transmitting the data means that letter, so they will see what mode of letter has to be reached to the receiver. So if it is a register or if it is a speed force or it is a normal letter, so depending upon the type of data or depending upon the type of delivery what you have requested for the postman, so means that is a post officer, so they will do it. So and they will furnish some their formalities. So means what, they will note it down the letter and they will put some reference number to that, and for that reference number they will dispatch it to, the letter to the designated destination. So at the destination, what they will do is, again based upon the reference number, they will check to which address the letter has to be dispatched. So they will deliver the letter to the corresponding home location where the destination has been present. And now, so what happens is, let us assume that, so in that home, whatever the letter it has been reached, there are 10 members are there. So among that 10 members, only one person has name has been mentioned in that letter. So what the postmaster will do it, he will deliver the letter only to the name to which the letter has been given. Okay, so means what, even though the letter has been reached to the home, it has to be reached to the specific person. Okay, so you try to understand why I'm explaining this, because you should understand what are the importance of each layer in the networking concept. So means what, so the data what you are going to write, so that will be in terms like a application layer. So for that application layer, so what you are doing is, you are attaching the source address and destination address. So you are just sorry me. Okay. So what you're creating a message, or you're creating the letter. So that letter information what you're creating, so that we can correlate it to a application layer. So the application layer will generate the letter. Next means information. So next what, it is a transportation layer. Transportation layer means what it does, it will does the end-to-end data transmission. So means what, Shreya is writing the letter to whom? So let's say Shreya is writing the letter to the Deepshi. Okay, so she will mention the name of sender and she will mention this name of the receiver. So means what, for that data she is attaching one more information. So means she is attaching one more type of information, or she is binding to that information, that is nothing but sender address and destination address. So now what they will do, the postmaster, they will attach some more information to that. So to which address or through which it has to be reached, how it has to be reached, they will attach their reference number. So means what, that will be done by the network layer. So what network layer will does is that it will transmit the data from one host to another host. So here in postmaster case, what it does is, it will transfer the data so from one post office to the destination post office. Okay, so it is nothing but host to host data transmission. So in the network, it is a device to device, whereas in the case of real estate, it is one post office to another post office. So that will be done by the network layer. So the next one is data link layer. So what is this data link layer is, if your information is too large, it is bulky, you cannot transmit it in a single stretch means, so then what they will do it, they will divide it in a fragments. Okay, so they will divide it in a fragments and they will put it in a small boxes, and for all the boxes they will give some numbering, flow number they will give you. So 1 2 3 4 5 6 7 8, so all these 10 belongs to same destination. Okay, so means what, fragmentation will be done if the information is bulky, so that will be done by the data link layer. So you try to correlate what we are trying to establish a communication in real estate with the network aspects. Okay, so the next one is physical layer. So what I said, physical layer, it is used to transmit the data, that is a bits of information will be converted into electromagnetic waves, so that the information will be reached to from a source to destination. Okay, so in real estate, what we do is, we will use some goods vehicles, or we will use some railway transportation to carry my information, to carry my letter from source address to the destination address. Okay, so at the receiver, what it does is, so it will reach the particular area or a city. From particular area city, it will go to the particular post office. So from particular post office, it will go to the particular area. From particular area, it will go to the corresponding address of the house. In that address of the house, so the letter will be reached. Of course, even though the letter has reached to the designated house, only authorized owner has to open it. So means what, Shreya has written the letter to the deep sea. So means what? Deep sea should open the letter. So means what? Then only the process will be completed. So from Shreya to deep sea, this data transmission we are going to call it as a transport layer. Transport layer means it is a transport layer of one sender to transport layer of the receiver. So means what? End to end communication. Next, from Shreya home to deep sea home. So that is nothing but the network layer. So means from home to home delivery or from device to device delivery. So that will be the host to host address. The next one is data link layer. So what I said, data link layer, if your information is too large means, so what I will do is I will fragment it, or I will make in the form of it is easily carryable. Okay, so that job will be done by the data link layer. Whereas physical layer, what it does is it will pack your letter in such a way that while transmitting it should not happen, or it should not lose its originality, it should not damage the letter. So we will pack it and we will send through some transmission media, either it may be road, it may be air, or it may be through water data transmission. Okay, so when you are doing, so what we should do is we should attach some addresses. Okay, so what we should attach some addresses, so that process we are going to call it as a encapsulation and a decapsulation. So you can see in the diagram, so the application layer will generate the message. For that message, in the transport layer we are attaching the number 4. So what is that number 4? Number 4, it is nothing but it is some header at the transport layer. So header at the transport layer, what it will be having, so what is the message, who has generated this message, where it has to reach, who is the receiver the message. So in case of Shreya and Deepshi, so that is a sender address and a destination address. The next one is network layer. So what the network layer will take, it will receive the data from the transport layer. So now you can see here the data which has been received in the network layer, it is not only the message, along with the message there is a header is of the transport layer, it is also there. So a header of the transport layer plus message will be the message, or we are going to call it as a payload in the network layer. So the network layer, what it does is again it will attach some address information to it. Okay, so it will transmit to the next layer, that is nothing but a data link layer. So in the data link layer, what we do is again we will take that message which has been generated from the network layer, we will attach some addresses. So means what, to check whether the flow controller to generate the frames, whatever I told, right? So it will attach that address, it will transmit to the physical layer. So what I told you, physical layer is responsible for bit stream to convert it into electrical signal. So that will be goes through the router, and through the router you can see here in the router, so the messages will be read, that is the address number 2. Yes, address number 2, it will goes and it will check in the routing table whether the address which is belongs to the destination or not, it will check. Okay, it is not, then where exactly it is there, means it will check the routing table. Based upon the routing information, it will forward the packet to the next. So you can see here in the destination, it will reach to the physical layer. In the physical layer, we will unwrap the means the preamble or a header of the data link layer, and then it will go to the network layer. In the network layer, it will check the address number 3, whatever it has been transmitted in the transmitter 3. If it is same in the receiver 3 means, then it will go to the next layer, that is nothing but a transport layer. So in the transport layer, it will check to which address the data has to be transmitted. So the data has to be transmitted to the some process, so that there the message will be transmitted. Okay, so like that, the same concepts we will be doing it in a networking concepts. Okay, so that is why we are going to call it as an encapsulation and decapsulation. So encapsulation means binding the addresses for the given messages. So the transport layer will take the message, it will bind its address. Now that will be the data for the network layer. So it will take it, it will bind some information. Okay, and then that will go to the data link layer, it will bind some information, then it will transmit the data. The reverse process will takes place in a physical layer. So what happens in physical layer? So first we will unwrap the address of the data link layer, we will unwrap the address of the network layer, then we will unwrap the address of the transport layer to whom the process has to be transmitted, so that the message will be transmitted to the application layer. Okay, so have you heard about some port numbers? Anybody, can you tell me what do you mean by port numbers? Yes, anyone? What do you mean by ports? Have you heard ports?
Sir, port number 16-bit signed integer.
Yes, once again tell me.
Sir, port number is a 16-bit unsigned integer.
And then?
Sir, you'll have, sir, we have protocols now, sir. So in those protocols, you'll be having different port numbers, as in 50 or 53 or something like that.
Okay, how many port addresses we have in our system? Can anybody tell me?
Sir, 6.
Only 6 port addresses. Can you just tell me what are those?
Sir, it will be in thousands, but I don't know exactly what is the number. Per IP address will have more than 1,000 ports. That is, I know.
But we will be having some port A, port C like that, no Shreya? What are those ports?
Sir, port A, port B. Sir, I don't know.
USB port A, USB port C, have you heard?
Yes, I have heard that.
And then what is the difference between these ports and whatever the ports we are telling? Is there any similarity? Is there?
No, sir. These ports are different, and the ports which you are talking about is different. The ports which which you asked me now, the number of ports, that is for the IP addresses and all those things. It helps in transferring the data. Like suppose if we have, okay, if we consider some number as 21, it will have some application which will control that. Like port number 22 is used to control a particular task or a particular application.
Yes, very good. Jayavardhan, anyone wants to add any information to this?
Sir, like file transfer protocols we have. Like in the last class you told about file transfer protocol, no? So I think file transfer protocol also has a port number.
Yes, very good, very good. Yes, anybody apart from this? What do you mean by ports? Okay. See, there are two types of ports are there generally. Okay, so the first one we are going to call it as a physical ports, and second one we are going to call it as a hardware ports. First one, and second one we are going to call it as a software ports. So the hardware ports are nothing but a physical ports where we transfer the data. So for example, so you can see here we have a port A address that is for the USB data transfer. Port C is there. Okay, so these are the physical ports what we have in our system to transfer the data from one device to another device. There are one more type of ports we have, that is we are going to call it as a software ports. So there are more than thousands of ports are there in order to transmit the data. See, since there are so many applications will be running in our system, and each applications will require us data to be processed, and it requires some input ports and it will require some output ports. So why it requires input ports is to receive the data, to process it. After processing it, it has to be delivered to some other process. Okay, so for each process, for each application, we require some ports, so that through the use of these ports we can receive the data from external entity and we can deliver the information to the external entity. So therefore, when we talk about a transport layer protocol, so this transport layer protocol is responsible for transmitting the data through port numbers. Okay, so for each application it has been divided into so many segments. After so many segments, it has been divided into process. So each process, it has requires a data, it requires a functionalities, what operations has to be done on the data. Okay, so when when it receives, and how it will transmit the data from one process to another process, so those will be done by the port addresses. So through the use of these software ports, we can transmit the data. Okay, so that is why, so you can see here in the application, means in the transport layer, so through the use of these port numbers only the message can be transmitted to the particular process. So that job will be done by the transport layer. So to which port address the data has been generated, it will mention it in the message, and to which port address, the destination port address, it has to go. So it will mention, so that corresponds to the header in the transport layer. The next one, the network layer. Network layer, it is responsible for device. So means what? This is the, for each device we will be having IP. So what it does, it will set the IP for only the system, but it does not specify to which process the data has to be transmitted by the network layer. So therefore, transport layer, network layer, it is responsible only to transmit the data from one system to another system. But whereas the transport layer, it is responsible within the system to which process the data has to go. So that will be done by the transport layer. So the next one is the data link layer. So the data link layer, it is used to generate the frames for your data transmission. So that will be done by the data link layer. So it will uses some error control, flow control information it will be uses. So how you can transmit the data successfully, for that we will be having some addresses. So that addresses will be attached in the data link layer.